All right. So when you first look at this thing, it might look, oh no, a little bit scary, but it's really not too bad. And sometimes we are able to let you guys kind of put together a very simple DC motor at home, just using some wire and a paper cup and a couple of magnets. And it's fun to see if you can get your little pretend motor working. But even this one is super, super simplified. But let's look at the parts and don't be scared. Here we go. Now, first in my head, I'm going to make sure I'm going to remind myself, all right, a motor starts with electricity and I want to make motion. I want to make something move. All right. So right here, you notice you have a battery. Well, that's my source of electricity. A battery has some chemicals on the inside of it, and those chemicals, when they are given a path, will release some nice little electrons and create some electricity. And you guys know that. You've used batteries and flashlights and things. So here's our source of electricity. And this little piece right here, I want to make it spin. I want to make it move. All right. So I want to start with electricity and make something move. So I'll show you how this is working. I'm going to watch it a little bit here. Okay. Now, here's what's happening. Here's the electric current. The electricity goes right through here on this little green wire. It's going to go up through here, and it's going to go right here. Now, this is a piece of wire, and I want us to think. Right here, we have an electric current from the battery moving through this piece of wire. Well, we know, or we should know, what happens right here. If I have an electric current moving through a wire, it automatically makes a magnetic field. And you guys know I don't do very well with these pens, but I'll do my best here. Wonder what color I should use. I'm gonna try blue, see if it works. All right, so if this is automatically, there's a magnetic field that's being generated here, right? And so in a real simplified way, I have a North Pole and a South Pole being created right in here because of the magnetic field from that electric current. So I'm just going to make it, I'm going to pretend, I'm going to put a little pretend magnet in there, right? Just to kind of, in my head, I want to remember an electric current automatically makes a magnetic field. So let's say there's a little magnetic field lines going through there. And just for fun in my head, I've decided, all right, there's kind of that pretend magnet. I can turn it off and on, right? If I remove the battery, goodbye magnetic field. Um, but if this is a North Pole and a South Pole, I'm just kind of picked one right there. All right, now this really right in here, guys, is just an electromagnet because it's a magnetic field that I can turn off and on. All right, but now I notice there's something else here. There's a permanent magnet in there, okay? You guys know, you can watch me struggle. Permanent. There we go. Here's a permanent magnet. Right there it is. And it's just hanging out. It's not going anywhere. Well, I want you to think about it. If this electric current goes through here and it's producing a magnetic field around this wire, and if I have a north magnetic pole here and a north magnetic pole here, what's going to happen? North pole, north pole, what will happen? They'll repel. And when that repulsion happens, this wants to spin away. It's like, I don't like you. I'm going to spin down away. And this south pole is also being repelled by this south pole. It wants to spin up and come up here and meet this north pole. And voila, we have motion. Now, that's nice. That was pretty cool. It would spin one time, but it would stop if it wasn't for this little piece of magic right there. That is the bee's knees right there. That is called a commutator. And you see how there's like a little space right there, little gap? Well, here's what happens with that little gap. I'm going to get rid of all this so we can see it really well. As this thing spins, when it meets that gap, it's kind of doing a little trick here. It's tricking it, and it's constantly changing the direction of this electrical flow. When it does that, it's constantly making the magnetic north and south pole that's being generated here flip. So just about the time that south pole gets, ooh, I'm going to come up here and get up to this north pole, we switch it. We switch it, and now it's a north pole, and it's like, boo, I don't like you. I'm going to go down here and switch it down. And just about the time it gets here, we switch it again. So let me show you how it works. Watch. You see how that blue and red, there's a gap. Blue, red, blue, red. So what's happening is as that spins, it hits that gap, and then it's changing the direction. So the easiest way to watch this, if I can get it really slow without stopping it, is, all right, so here's blue. Here's the direction of the flow. See that arrow's going to the right. Now watch the blue when it goes down. Okay, so right now that arrow's going to the right. Now watch. Ooh, now here's blue, and look at the arrow. It's going to the left. Tricked you again. Blue, showing you the direction of flow to the right. So we're constantly switching the magnetic north and south pole of this magnetic field that's being generated by the electric current. And that constant switching, tricking it, is going to continually make it attract and repel, attract and repel, attract and repel. And hopefully you have electricity making motion. And that's how that's how a motor works.